The first part of the problem asks us to determine the bottleneck and process capacity for a given system. The bottleneck of a particular process flow is defined as the resource with the lowest capacity. And then the capacity of the bottleneck is also the system's process capacity. Let's start solving this problem by creating a table where we can track the capacities of each of the available resources. Capacity is defined as the number of workers over the activity time. So for resource 1, we know we have 2 workers and an activity time of 10 minutes per unit. This capacity is currently in terms of units per minute. Let's convert this to units per hour by multiplying times 60. And we get 12 units per hour as our capacity for resource 1. Similarly, for resource 2, we have 1 worker and an activity time of 6, which results in a capacity of 10 units per hour. Finally, for resource 3, we have 3 workers and an activity time of 16 units, which results in a capacity of 11.25 units per hour. Since the bottleneck is defined as the resource with the lowest capacity, we know that the bottleneck in this example is resource 2, which has a capacity of just 10 units per hour. This also means that the process capacity of the system is equal to 10, since the process capacity is the capacity at the bottleneck. The next part of the problem asks us what the flow rate would be if demand is 8 units per hour. Since the flow rate is equal to the minimum of available input, demand, and process capacity, we must compare the demand rate of 8 units per hour and the process capacity of 10. The minimum is 8 units per hour, which then is equal to our flow rate. In this example, we are demand restrained. Finally, we can compute the utilization of each of the resources. Utilization is equal to the flow rate divided by the capacity. Therefore, for resource 1, we know the flow rate is equal to 8 units per hour and a capacity of 12. For resource 2, we have a flow rate of 8 and a capacity of 10. And for resource 3, we have a flow rate of 8 and a capacity of 11.25 units per hour. Each of these fractions represent the utilization for the respective resources.